Welcome to all for GATE lecture videos. I am Dr.V.CHOUDRI, Associate Professor, Department of Mathematics, working in SCA Engineering College. In this session, we are going to see one video regarding GATE lectures, especially for calculus. The calculus is very important topic in mathematics. First, in calculus, let us see functions of single variable. Functions of single variable. So, in school days itself, it is very familiar. Most of the students have studied f of x. Do you know what is the meaning of f of x? F is the function of x. That is, x is only the single variable. We can take the relation f from the single variable x only. Okay. Now let us see the definition. Definition of a function. A function f from a set A to a set B is a rule that assigns to each element x belongs to a unique element y in B. Usually, you know what is set? Set is a collection of distinct objects. Here we are taking two sets, that is A and B. Okay, set A, collection of some elements, set B, collection of some elements. Here, what is a function? It is assigned every element x, a unique element y in B. A unique element y in B. Now, see the diagrammatic representation. Here I am taking domain x1, x2, x3, x4 and codomain y1, y2, y3, y4. Here what is the function? F from x to y. X is the domain, y is the codomain. Here f is related between domain and codomain. It may be x1 with y1, y2, y3, y4 or x2 with the elements, x3 with these elements or x4 with these elements. So what is the functions in this function? x1, x2, x3, x4 are input values. After substituting these input values, we can get some output values. These are y1, y2, y3, y4. Okay, so based on the relation x1 relate with y1, x2 relate with y2 or x3 relate with any of the elements. Okay. See, practical example. So this is the switch box. Often you have seen several places, house, working place or college, some other places. Okay, so several switches are there. It may be used for a ceiling fan. It may be used for plug point for charger purpose. This may be for cable connection. This is main switch. This may be dummy or any other purpose. Okay, here I am giving you some examples. Ceiling fan, smart TV, and system, and lights. Not only this, some other electronic items also. Okay, so just imagine that some gadgets are available in our house or any other working place or any other institution or something. Okay, now how do you relate the function concept with these examples? So this is the domain connected with the codomains. This switch may be connected with the ceiling fan. This switch connected with the smart TV, or this switch may be connected with the system. This switch may be connected with the lights. Okay, so when we operate these switches, we can get the output of these gadgets. Okay, you are watching serial and college work, lights, something, etc. Okay, let us define by the domain and the codomain base. Okay, in x values, in set x, I have taken all the switches. Don't see the colors, they are white and red. Just an example, like switches. Okay, and the codomain, I have taken what? The electronic items, system, bulb, instead of ceiling fan, I can take a refrigerator and etc. Okay, now this switch, second switch, connect with this bulb. What is the meaning? When we operate the switch, we can get the output of this bulb. Okay, second, first switch, See, the first switch also connect with the same bulb. Often you see in bedroom or in terrace, two switches connect with a single bulb. Okay, and see the third one. Third one connect with what? Maybe system. Nowadays the system, smart TV, it may be connect with the refrigerator. Refrigerator also, that is your wish. And here fourth switch, where it is connected? Yes, it is connected with the refrigerator. Okay, see, in out input values, all the x1, x2, x3, x4 are connected with these electronic gadgets. But the output, one thing is missing, that is what? System. System may be not connect with any switch, but all the switches must be connected with any one. That is important one, because in the switchboard, if it is, do you want to keep any unnecessary switch in this one? No, that is the concept. Now my question is it the function? What's your answer? Yes, it is a function, because input values, all the values are assigned with output values. Okay, suppose any switches are missing here, is it a function? Let us see next example. See, I took all the four switches and the electronic items, two connect with okay, bulb. Same two connect with system. Three connect with TV, and fourth connect with the refrigerator. Now my question is, you have in switch boxes, four switches are there. One switch connect with the two outputs. Suppose you want to switch off the light. Can you switch off this light? If you switch off this light, the system automatically switch off. Is it good one? No. So our conclusion, is it a function? It's not a function. Because one more concept is there. Here one is not assigned with any element in Y. What is the concept? See, a function f from a set A to B is a rule that assigns to each element x belongs to A. So domain, from the domain, each element a unique element y in B. But here one switch is not connected with B, so that we couldn't say that this is not a function. Okay. So our mathematical conclusion, it is not a function. Next, we come to this domain. Right. Here, a function f of x. F is a function of x, is a single variable. What is the input values? There is points are taken only now. The domain, that is called a domain. Domain means we are providing the input values from certain set. That is called a domain. Sometimes domain values are taken from range, domain widely, sometimes with the condition. Let us see what are the possible chances for domain. See, x-axis and the y-axis. Here the function is f of x only now. So x is the input values, y is the output values. Okay, so x values are domain values, y values are codomain values. Every real values of x-axis. Suppose domain values are every values of real axis. Every values of real axis means left hand side up to minus infinity, right hand side up to plus infinity. So how do you define the domain value? See, arrow mark, left arrow mark, right arrow mark. That means it covers left hand side and the right hand side. So it represents that you can take any values between minus infinity plus infinity, that is domain. Okay. Minus infinity comma plus infinity. Next, piecewise. Certain cases, f of x, you are allowed to take minus infinity comma a may be the negative value. So from this point a to minus infinity, after this point a, it is not allowed, but a to b is allowed. After this, b to infinity. So there is gap, you are not allowed to assign x values from these values, only between these values. That is called a piecewise domain. That is called a piecewise domain. Okay, so previously you are allowed to take every values of minus infinity to plus infinity, but here some restrictions are there. You are not allowed to take here and here. That's why it is called a piecewise domain. Okay, now we come to the range. So domain represented by x-axis, codomain or range is represented by y-axis. So what we have discussed for domain, same thing for range also with the y-axis. See, in order to x values, we are getting the output values minus infinity comma infinity, like that piecewise. See this except minus d and except plus d, all the values. So already it is covered minus infinity comma plus infinity except c and minus d. Okay, that is piecewise range. See, intervals may be represented. Okay, sir. Now previously you said minus infinity comma plus infinity and the piecewise something. So how do we represent by the intervals? That is very important. To define the domain and range, we are using some ideas to identify the intervals. Open interval a comma b. I am using here open parenthesis and closed parenthesis. Okay, so what is the meaning of open interval a comma b? You are allowed to take in between a and b, not the value at a, not the value at b. That is the concept. So next, including a and b, that means closed interval a comma b. Between a and b, also we may assign a value and b value, that is closed interval a comma b. Sometimes closed interval a, open interval b. So in between a and b, and you are allowed to take a value but not b. Sometimes you are not allowed a but allowed b, that is open interval a comma closed interval b. So these are the basic concepts to understand domain and range. Now real valued function. We have seen what is f of x, and in this session we are going to see only the real valued function. So whatever we take the x values, the corresponding results must come for real valued function. That is, here x is a real, so f of x is a real valued function. Here the image fault function. In case f of x equal to square root of g of x, we define the function f of x equal to root of something function. Okay, so as per the condition of real valued function, here g of x must be positive. Why it must be positive? Suppose g of x is negative. What happened? Root of minus into something. The result comes plus or minus I. Plus or minus I. Once the answer comes with the plus or minus I, it comes under complex numbers. So that negative values are not allowed. G of x must be positive. In other case, same g of x, if it is placed in denominator, f of x equal to 1 by root of g of x. First, g of x must be positive, that is allowed, and also not equal to 0. Here equal to 0 is allowed, but here not equal to 0. Why? If it is equal to 0, 1 by 0, 1 by 0 value equal to infinity, that is f of x does not exist. Okay, so these are the main condition for real valued function. Okay, x should be real. Next, domain of equalities and inequalities. When you represent the equation, when you represent the function, it comes with symbols equal to and inequalities. How do we define the domain? Let us see. If x minus 1 equal to 0, this is for equality. This function equal to 0. So what is the answer? X equal to 1. If it is x equal to 1, how do we define the domain? Only x at 1. So in x-axis we represent only x value equal to 1. So here there is no record of mentioning intervals. What are the intervals we can say? Open interval a comma b. See what are intervals we can discussed? Open interval a comma b, closed interval a comma b, closed interval a, open interval b, open interval e, closed interval b. Okay. So in this one there is no requirement of intervals. Next, inequalities. If x minus 1 less than or equal to 0, x minus 1 less than or equal to 0. When you bring this minus 1 to right hand side, it comes x less than or equal to 1. So here whether we represent the single point or interval. Let us see now. X less than or equal to 1, x value not only equal to 1, x less than 1. So what are the values are x less than 1? 0, minus 1, minus 2, minus up to minus infinity. So here we use the interval. See the x-axis, I mentioned the point x equal to 1, not only x equal to 1, less than values of 1, that is minus equal to up to 1. See? Next, other inequalities. X minus 1 greater than or equal to 0. When you substitute x values here, answer may come equal to 0 and greater than 0. Greater than 0 means 1, 2, 3, 4, 5 up to infinity. So here we use the interval x greater than or equal to 1. See, I denote the point x equal to 1, not only 1, greater than 1 to infinity. So the interval of the domain, closed interval 1, open interval infinity, because 1 is included. Let us see one example. Find the domain and range of f of x equal to square root of 4 minus x square. So given f of x equal to square root of 4 minus x square. Okay. Already we have seen that we have f of x equal to root of g of x. Inside the function must be positive, because here we are taking real valued function. So as per the condition, what is the 4 minus x square? That should be greater than or equal to 0. Okay, so 4 bring to right hand side, minus 4. Multiplying minus on both sides, what comes? X square plus x square plus 4. Change the symbol here, less than or equal to 4. Okay, so x square is equal to 4 means x equal to plus or minus 2. When we use less than or equal to 2, it comes this interval minus 2 to 2. In next class, I will explain whenever we have less than or equal to, greater than or equal to define the domain values. Let us see in next one. So here just you understand minus 2 to plus 2. Okay, so what is the domain? Minus 2 to plus 2. See by the diagram, in x-axis minus 2 denoted in x-axis and in between the values. This is the domain. Now let us see the range. For the range, what is the function is given here? F of x. Let us consider y equal to root of 4 minus x square. Multiplying, taking square both side, y square equal to 4 minus x square. Bring this minus x square left hand side, x square plus y square equal to 4. This is the equation of circle with the center 0, 0. So what is the equation of the circle? X minus a whole square plus y minus b whole square equal to r square. In the place of a and b, there is no number is there. So 0 and 0. The place of r we have 2 square, that is what? 2. Okay, or draw the curve using the domain value. Here the curve is well known, you know the circle, that's why I identify with the circle. Otherwise, suppose the given equation is not well known. How to identify the function? Using x values and y values. So x values, what is the domain of x values? Minus 2, 2 and between the values. So I take the x values minus 2, minus 1, 0, 1, 2. When we substitute x value equal to minus 2. See, substitute x equal to minus 2 square 4. 4 minus 4 value 0. And x value equal to minus 1 and the plus 1. Minus 1 square value plus 1. Plus 1 square value plus 1. 4 minus 1, 3. So y value equal to root 3. When x value equal to minus 1, y value equal to 1, root 3 and root 3. Okay, so draw the curve. X-axis, we note it down, x equal to minus 2, x equal to 2, and all the points. It comes a upper semicircle, y equal to root 4 minus x square. If it is y equal to minus root 4 minus x square, means it comes lower semicircle. Okay, this is the range of the given function. Okay. Now in this video, what we have discussed in calculus, function of the single variable. In function of single variable, what is the function? How do we find the domain and the range of the given function? Especially function is a real valued function. So after that, limit, continuity and etc. So these are the basic concepts of the function. If we know these concepts only, we can do the following problems. Okay, thank you.